There are two topics comes under this pre-videos. In this I'll be first topic will be covering in this video, and next topic it is to only problems. We'll be discussing it in the next pre-video. These are the two topics, very important topics I bring it today. So let us discuss with one topic is how to prove that whether given language is regular or not. So far you have seen that what is language, what are the regular languages which is recognized by DFA or NFA and NDFSM. And also you have seen some of the regular expression properties. Now also seen in the previous pre-video, we'll discuss what are the decision properties. Decision language, finite, infinite, emptiness test. Okay. So all this all together understand now. We are concluding that is so far it is accepting only regular languages. Is that all the languages are regular? You cannot. It may be there is some of them are not regular. Then how do you prove them it is a regular or not? Is it by is it by using some procedure? Definitely you have to use the procedure. Is not possible to seeing language is regular or not directly, cannot say. So then the question is arises when is language is regular? Absolutely there is simple answer is which is recognized by finite automata. When it is accepted by finite automata, then it is RDFA, then you can say it is a language is regular. When is it not? Then you can language is not accepted by finite automata, then you can say it is not finite automata. So simple answer, you can able to answer it because so far you have learned so many points on these languages, regular languages. How to prove languages are not regular is not by using some hierarchical concept or heuristic approach is not possible. You have to use some, come up with the some FAI over there. Can it be language that is not regular, or is that we try to wrong approach? All this will be very decisive prove that language is not regular. The hardest thing of all is to find the black cat in a dark room, especially if there is no cat. So this by saying this says all hardest thing of all is to find a black cat in a dark room, especially if there is no cat. It is very difficult now. So then I can see that example non-regular language, let L is equal to W such that W is of the form 0 power n and power 1 power n for all n is greater than 1. What is the hypothesis here? L is not regular. Why is L is not regular? Because there is a n number of zeros followed by n number of ones. So there is always start with a 0 followed by n, right? That means this language generating n zeros and followed by n number of ones. So how do you keep track of this trunk? So DFAs fail. So it will not possible to store n number of zeros. Suppose there is a 5 zeros, that many number of ones should be track. Before tracking one, 0 should be stored somewhere else. There is a limitation over the DFA. So that is very difficult. So that is not recognized by DFA or NFA. So initiative rationalize, how do you keep track of running count in a FA? That is very difficult. This is very difficult task. This is not easy to prove since there is an infinite number of them. Okay. So solution you have to use here, pumping lemma. What is the solution you to use? Pumping lemma. So that is not. What is pumping lemma? Pumping lemma is a lemma is a scientist name. He'll be using his name to produce derive one of the theorem. That theorem will using it to prove that language is regular or not. What is that language? There are two ways you can be do it. One is by regular language, another is by context-free language. There are two pumping lemma comes in your course. One is by regular language, which is currently studying. Another pumping lemma comes in a module 3, that is context-free languages. So when you learn this pumping lemma for regular language, then it will be easy for you to study context-free pumping lemma. So with that, how to prove this pumping lemma for regular languages? What is it? So property for all these languages, how is it used? Technique that is used to show that given language is not regular. That is what it is. Statement and proof. So it is very important, dear student, in an exam point of view. They will don't ignore this theorem, pumping lemma for regular language. They might be asked for 8 marks. So it has been appeared many number of times in VT question paper previously. Last 10-year question paper, if you refer it, at most it will get 8 times, right? So that I am emphasizing again, it is very important theorem. Please you have to take down it, right? The statement will be like this: let L is a regular language, then there is an integer n, so that for any x is belong to L with length of x is greater than is equal to n, there are strings u, v and w, so that x is equal to, these are the four subsets are very important. X is equal to u, v, w, length of u is less than equal to n, length of is greater than equal to 0, for any I is greater than equal to 0, then u, v, y, w is belong to L. So these are the three properties very important to understand. So next, proof. How do you prove them? Let again this by DFA and accepting L having n number of state. Then let x is equal to a1, a2, a3, etc. m be an arbitrary string. Suppose if I take an arbitrary string such that m is greater than or equal to n, x is in L of m. And a delta of q naught comma a1, a2, etc. am is equal to qm. If m is equal to n, then delta of q naught comma a1, a2, etc. am will have a m plus 1 state, but there are only n state, therefore some state must have a loop. Therefore two integer j and k where j is greater than equal to 0 and j less than equal to k, such that qj is equal to qk. So how do you represent this? We'll see. So you have taken a let u is equal to a1 to aj, then v is equal to aj plus 1 to ak. That question mark is missing is a etc, etc. So in this iPad is not supporting, so that symbol dotted lines, that is so while transferring from my desktop to the tab, it is indicating that, it is indicating this, it is a dot dot dot. Okay, so don't get confused. And v as a minimum length 1 and maximum length n, right? Formally how do you write it here? So look at that, delta of q naught comma a1, a2, etc. aj plus 1 to ak, k plus 1, which is resulting state qm. Again, if I split it, you know, extended transition. So if I split like this, you will get this result. You could go around the loop more than once, thus what is the result? So that means you are going around the loop, means it is a I is equal to, I become a loop. U, V, I, W is equal to A1 to AJ, then AJ plus 1 to AK over I, AK plus 1 to AM is in L of M. For all I is equal to, for all I greater than or equal to 0. So how do you write it in a graphical way? Look at this. This way you can, first it is a U, this is V, this is Z, W. So it is means You can prove that. In other words, when processing the accepted string x, the loop was traversed once, but it could be allowed to traverse as many times as desired, and the corresponding string would be accepted as many times greater than equal to 0. So how do you split that? This means it is a1 to a2, aj to aj plus ak, like that it will be dotted it. So how do you represent this? By q naught and aj is equal to qj is equal to qk. This you can write it. This will be the path. Anything it will come between this, that label a1 it may come, a2 it may come, like that it will be up to aj. Once you reach to qj, qj might be equal to qk when it is become a loop. So that loop it can be repeated as many times as aj plus 1 time to ak. Suppose there it be one more path, because when you reach to the final state qm, so that may be any intermediate state it may come, like after using this path ak plus 1 to am, right? So same state, and so for loop greater than equal to 1, it is for k is greater than equal to 1. What is an application? Now so far I understand the state and proof of pumping lemma. What is that application? Application is like this. Any language is given, we have to test it whether it is a regular. If we say regular, it satisfies all the properties of pumping lemma. If not, does not satisfy pumping lemma, it is a non-regular. This is the main application. What are those methods to prove that language is not regular? At first you have to assume that L is regular. Always, before you cannot take the conclusion by seeing the problem, you have to assume that given L is a regular. Then apply the sum of the properties of satisfy the pumping lemma, then hold it for long. Then you can say that what are those properties. Any language as given, you have to select it is like that, x is equal to uvw. Then you have to length of the x is greater than equal to n. Select v such that length of v greater than equal to 1, and x such that uv length of u is less than equal to n, assigning the remaining string to w. For all I greater than equal to 0, u vi w is equal greater than belong to L. Hence else, so if that is satisfied, hence say L is not regular. It is satisfy all this. So I think I have discussed this application. Please, dear student, remember this. State and proof of pumping lemma and application of pumping lemma. Understand the concept again, rewinding my video again and again. Understand the concept. If not understand, because since it is all assumptions are there, some of them have to be take few example on the board. I will be discussing in the classroom. Till before to that, you just listen the video and come to the class. The more concept will be clear. So with this I will be winding.